Dude, here I going to tell 13th video of the trigonometry. Here they have given angle A and B are acute angle such that cos A equal to cos B. Then show that angle A equal to angle B. Now I going to tell what's the meaning of this one. First, let's take two imaginary triangles. Now I going to take this triangle and another one triangle. This triangle going to become angle A lies in this triangle and angle B lies here. Here you can take it as APQ triangle, right angled at P, and here it is BXY triangle, X is right angled. Now let's find it out. They have given here what is that cos A equal to cos B. Now you're going to get here cos A equal to cos B. Here the triangles are given. You need to write adjacent, hypotenuse, opposite. This big side is hypotenuse here, and even here it is hypotenuse. But here this is angle and this is opposite to the angle is opposite side, and adjacent to the angle is this one, joining angle is adjacent side. Here also this angle, this is joining side, so it's going to become adjacent side, and now this going to become opposite side, opposite to this angle. Now cos value means adjacent by hypotenuse. Here also it is adjacent by hypotenuse, and here also it is adjacent by hypotenuse. Now here what they have given is like this, that is adjacent by hypotenuse and adjacent by hypotenuse. Here it is PA by QA. You're going to get PA by QA equal to this one XB by YB. Here XB by YB, it is adjacent hypotenuse, it is adjacent hypotenuse. Let's take them as equal to K. Now if you send this side, that side, it's going to become PI is equal to K times of QA, and here XB going to be equal to send YB that side, K times of YB. Now let's take in these two triangles. Here you can take like this. In these two triangles, here we get PA by QA equal to KXB by YB, that is XB by YB. You need to prove that even that QP by XY is also equal to K. You can rewrite this problem, that is PA XB can come here and QA can go there. It's going to become PA by XB equal to QA comes up, QA by YB, which going to be equal to K. So you need to prove that PA by XB, this side by this side, equal to QA by YB, this side will be equal to this side, and this side going to be this side by this side. Those three ratios going to be equal to K. So these two triangles going to become similar triangles, and angle A going to become equal to angle B. Let's prove that thing. First let's take these two triangles, that is in triangle, first this triangle PAQ. In triangle PAQ, this side square plus this side square is hypotenuse square, that is QP square plus PA square. QP square plus PA square will be equal to QA square. Now you send this, we need QP, so send the PA that side. QP square going to be equal to QA square minus PA square. Now QP will be equal to root of QA square minus PA square. In the same way, even take this triangle, that is YXB. In triangle YXB, you're going to get in triangle YXB, here this side square plus this side square equal to hypotenuse square, that is XY square plus XY square plus XB square going to be equal to XB square going to be equal to hypotenuse square, that is YB square. Now if you send this XB that side, we have XB, that is XY square. We need side XY, so XY square going to be equal to YB square minus XB square. Now you need to prove that send square that side. XY will be equal to root of YB square minus XB square. You have this thing, that is XY and QP. Now you need to prove what is that QP by XY going to be equal to K. So let's take QP by XB, that is what is that QP by XP, QP by XY, QP by XY. qp by yx. Qp by xy will be equal to, here I found it out, that is root of qa square minus pa square. Root of qa square minus pa square, here divided by root of this one yb square minus xb square. So you're going to get yb square minus xb square. Now this pa can be written as k minus qa, and here also xb can be written as k times of this one, k times of yb. Now you can substitute here the same thing, that is y can be written as q times of 1, and x can also be written as q times of this one. Here you must not take this thing, instead of this you can take here you must take ratio. Pa is k times of xp, here pa equal to this xb go that side, k times of xb, and here qa going to become equal to k times of yb, and square of that going to become square for both. Pa square equal to k square xb square, and here qa square going to be equal to k square yb square. Now you must find it out this one. Here instead of p square substitute this thing, instead of q square substitute this thing. That is you're going to get, after plugging in, q square is k square times of yb square minus p square is k square times of xb square. Now divide it by root of yb square minus xb square. Now you're going to get like this. Take k square common in them, it is k multiplying. You're going to get k square times of yb square minus xb square, and here also root of yb square minus xb square. This k square comes out, and root and square cancel to become k. Root of yb square minus xb square, here also root of yb square minus xb square. Now you're going to get completely cancel this out, so it's going to become equal to k, that is qp by xy. So this is nothing but, here these two are equal, so even qp by xy is also equal to this. So this triangle, these two triangles going to be similar, that is triangle qpa going to be similar to x triangle yxb, here qpa yxb. So angle of this going to be similar. What is that angle? Angle A will be equal to angle B in similar triangle. Angle A will be equal to angle B, and that similarity is known as SSS similarity, side similarity. Bye.